As you already learned, Docker is the software that enables containerization. But it is also much more than that. Let's start with the basics. Do you remember the ice cube analogy from the beginning of this chapter? There, I compared an ice cube to a container and said that an ice cube holds water, the application and its dependencies, in a very specific frozen state. That cube started its life as water. To get an ice cube, you need to pour water into an ice tray. This tray will always give you the same result in terms of the shape of the cube. This is precisely how Docker images work. You start with your application. That's the water. Now you need an ice cube tray. In Dockerland, a Docker file is the ice tray. It's a text file which defines line by line how the image should be built. In other words, the Docker file gives shape to your application's image. Okay, so far we've got the application, which I compared to water, a Docker file, which I compared to an ice tray. Now we need an environment where the temperature is low enough for the water to freeze, or in terms of Docker, we need an environment where we could create our image. For that, we need a fridge. The fridge, from our analogy, is like Docker daemon. It's responsible for taking Docker file, build instructions inside of it, the run command, and creating a corresponding Docker image out of those pieces. It's also responsible for starting a containerized application based on its Docker image. In other words then, Docker daemon is the piece of software that brings all of the other pieces together, from building application image to running the container with that application. What's really cool about Docker is that you can install it on any major operating system, for example Windows, macOS, and Linux. This is particularly important because Windows and Linux are the most popular operating systems for cloud-based servers. If you wanted to run your application in a container in the cloud, which is the new standard, your deployment target, in other words, the server computer to which you'll deploy the application, needs to be able to run a Docker container. When doing deployment, you usually include the Docker file in your application's code. The cloud-based server can then take that Docker file and build your application in the exact same way as it would do on your local computer, and then run it. For the application image to be complete, we need one more thing, which is the base image. It's a snapshot of a file system with all the things that your Dockerized application needs to function properly. It includes all of the base software, like the operating system components, and software for the operating system components to understand a programming language that your application is written in and to run that code. This is what you specify in the Docker file as the base image. Once all of those components are in place, you can build your image. Another Docker feature is a Docker CLI, a command line interface where you give command directly to Docker, in this instance to build your image. Image building is where Docker does its magic. Base image uses a system of reusable layers shareable across different images. Each of the layers represents things like stripped down version of Linux operating system, system tools, so selected pieces of the operating system, and software for running a programming language. All of the layers not present on your computer are downloaded from Docker Hub, a cloud-based library of images, which is another Docker feature. To summarize, Docker is a fully featured and complete ecosystem for building containers. It includes the Docker file, which is the template for building application image the same way on any operating system. Docker Hub, which is a library for published images, such as base images. Docker command line interface, which enables the user to control Docker on their machine via Docker commands. Docker daemon, which is responsible for bringing all of the other pieces together, pulling images from Docker Hub, building the image, and running the container based on that image. In the next video, you'll see all of these components of Docker in action.